Hello, hi, good morning to everybody. Thank you for joining today's webinar on Beyond Reality, how the virtual reality is transforming worksite safety, a webinar that is hosted by Professor Jochen Theiser of the Technical University of Technology of the Department of Civil and Mechanical Engineering, that will, as the title suggests, also will take 30 to 40 minutes to introduce and present, together also with specific short videos, will provide insight on how virtual reality and a digital, let's say, immersive environment can provide workers of the construction sector the possibility to practice, to get training in a safe and protect environment compared to what is currently done usually in the working sector, where workers are trained also in hazardous real life environment. Now, the importance of the technology that the solution that the professor will share with us today are also connected to the possibility for the trainer to actually collect a very precise number of data on the performance of the worker, as well as obviously consequently provide way more precise and personalized feedback on the performance of the person involved in the training session. Now, this webinar will actually have a Q&A session at the end after this 40-minute presentation by the professor. And I will not actually take much time still of his time for presentation, but I just want to give you a sort of insight on why this webinar of today. This is actually part of a series of events that are meant to showcase the different technologies and solutions that the project BEEYONDERS developed during its lifetime. BEEYONDERS is an EU-funded project that is currently in its fourth and last year of life, and which during its lifespan produced and advanced a series of solutions that are essentially meant to achieve the main objective of the project itself, which is ameliorating, renovating the construction sector by making it more attractive for young generation, more competitive in the sector, both within the EU market and internationally, as well as making the construction sector less impactful from an environmental point of view, thus having technologies that emit less CO2, quite simply. Of the many technologies that the project developed, we have, for example, autonomous wheel loader or autonomous vehicles capable of moving autonomously without a pilot in the cockpit, thus performing tasks in dangerous environment, allowing the workers not to take part with their own presence in those places, and also solution like the one that the professor will share with us shortly. Now, should you have any question or any doubts, as said, concerning today's webinar, the professor will be available to provide any answer at the end of the meeting. Today's webinar will be recorded, actually still, we are currently recording it, and it might be made available, if not immediately after today's meeting, in the coming future. Obviously, you will all be notified by time when this will allow and will occur. And we will also share in the chat the link to the website of the project so that you are more than welcome to investigate and navigate it for you to have a look of the various technologies and the various solutions that the project provides. So without further ado, I will actually now leave the floor to Professor for a brief introduction of himself, if he wants to, and to the presentation of the proper webinar. Thank you.
Good afternoon. My name is Jochen Theiser. I'm a professor at the Department of Civil and Mechanical Engineering at DTU. The work I'm presenting here is actually mostly generated by Kilian Speiser, an extremely sophisticated PhD student who's about to graduate soon. The title is Beyond Reality, How VR is Transforming Worksite Safety. Speaking of that, both Kilian's work for the past 3 years as part of the BEEYONDERS project, as well as my lifetime work with respect to construction safety, very much relates to a couple of topics, which I will introduce first, and maybe showing a little bit the framework, and then going into the specifics about how virtual reality can assist. I'm not sure if you are all experts in these topics I will present, but I'd rather present quickly and fast so it's not boring. And then please feel free to ask questions at the end of the presentation. I think that's the best format, and I appreciate that you are here today. let's continue. Agenda. I go a little bit into motivation and background. Then I introduce the digital twin for construction safety concept, because virtual reality is part of it, where we have three main components. One is prevention through design and planning, where we design out hazards. The second part is construction site monitoring and control, and we want to do that proactively. And not last but not least, maybe it's actually the first. We want to do personalized learning, and here virtual learning environments can certainly help us perform change. I think I will go into that. And then at the end, I have some key takeaways. Motivation. Well, we all know that safety is very important, especially in construction. The construction industry is one of the worst industries to work for, since its work environments are very complex, very dynamic, and many of the accidents that occur, and I cite here the OSHA 4-hour Fatal 4, it's falls from height, struck by injuries, like being struck by a load from above or from workers, being hit by a machine, caught in between, let's say being in a trench or other hazardous workspaces or confined workspaces, and electrocutions. And the list can go on and on and on. The industry, as well as research, has focused a lot in the past decades on lagging indicators. These are recording safety statistics, basically reacting passively upon happenings. We call them incidents. And these incidents are being followed up with. But it's too late. Somebody got injured or even killed. It's simply too late for us to take proactive measures. And that's why the industry has slowly moved towards looking into close calls. That was about 20 years ago. Close calls, recording also events that almost lead to an injury and fatality, and preventing those. And even now, the focus is continuing to be on high energy assessment control. This means watching out for impact of the force that hits a worker eventually. And the reason why this is shifting towards high energy control assessment is simple. We haven't reached the zero accident goal yet. You can see this here in the bottom of the curve. There's two curves, the green one and the red one. It's actually produced by CII on an annual basis. And even though it's a lagging indicator, it shows clearly there has been tremendous improvement in workplace safety in construction, and yet we haven't reached the zero accident goal. The industry that is doing, or the part of the industry that is doing extremely well, we call them leaders. They take best practices and they perform 10 times better than the rest of the industry, which is indicated here by the darker curve. Of course, all of that relates to work hours put in place, but typically we see an increase in safety performance, and yet we are not down to zero accidents. Some criticize if that is a realistic goal. Some people say it's not possible. Honestly, I don't care about it. And the reason is we can still have a huge way to improve over time, which means the zero accident goal, even though it's a bit emotional, I think it's a nice target to keep working towards. Anyway, so that sets the base. I give you a couple of examples of accidents in the Nordics. Well, actually also one in Germany, almost the Nordics. But the Nordics are performing typically very well in safety, even though the construction industry is relatively small. But tragic events happen. And things have to change, right? And typically what the industry applies is the high-level control theories. They have been around for 30, 40 years now. And they basically say we need to get a cultural change, the CEO at the top approving and going all the way down to the worker level, providing safe worker training, safe site conditions. And yet it is not there where it should be, and that's where I added this layer of protection. Actually, you may think these are Swiss cheese, slices of Swiss cheese, and each hole in the Swiss cheese slice actually is an incident. And the further you go down, these incidents decrease because the holes are covered. But yet, so far, as you have seen in the statistics, it hasn't been, we haven't achieved the zero accident goal. And I'm a firm believer, and that's why I've introduced about 20 years ago this level of digitalization. Reason had not foreseen that He stopped at personal protective equipment down in the hierarchy level at the very bottom on the site. But I believe digitalization can add another layer of protection, not erase all, but certainly assist us. And virtual reality or training with VR is a part of digitalization, where I also state that digitalization is seen as an enabler, but certainly not as a replacement of human skills. So workers will not go away for the foreseeable futures, probably in 50 to 80 years. Yes, we will have automated construction sites similarly to a factory plant environment that we see in the automotive or the airline industry. But workers will always be there to assist. So we have to even make those highly progressing work environments even safe when robots and other autonomous systems are in place, which actually BEYONDERS targets as well. BEYONDERS has a teleoperated autonomous wheelloader, and here we have to take care and apply protective measures so workers don't get injured or killed. Now, we have a construction site, just to introduce the framework a little bit. I do it quick, but we typically plan digitally on construction using building information models. Some of you are familiar with that. But that information that is stored in these building information models can be given to trade workers. They can instruct them, and they can work accordingly, hopefully safely, on time, on schedule, with high quality. And yet, even very modern construction sites have mobile devices where things can be reported, either the work progress or actually also safety hazards. There's a well-known software company from Denmark that actually provides such very easy-to-use manual devices. And you can see already these are typically manual devices where you have to enter and fill out a form online, which is reported, linked to the BIM model. Very nice, but still a lot of stuff happens manually. And yet, even though it's manually, the construction safety management or the construction management benefits from it, from information that previously was not digitized or has been reported from the field, which is good. And yet we're missing one important piece to round up the circle of information because we want to go circular, right? Circular not just based on sustainability and materials, but also in terms of the flow of information. We also need to think about how can we advance learning environments, especially for construction safety and health and well-being. There's really good opportunities there to close the loop and provide consolidated feedback, actually feedback that relates to the project, that is based on progress. I think that's a very good pathway to close the loop of information and actually make sure the next design of a building follows the lessons learned from the previous work sites. To continue there a little bit, of course, this is not just a nice, pretty framework that we have thought of, or I've thought of over the past 20 years to create. There's a lot of technology in the background. We call it digital twin for construction safety. We've introduced here papers in 2022 to 24. This is one of the latest versions because it's also evolving over time, as you can imagine. It looks very complex, but let me show you here. We have a construction site that has a lot of data. First of all, we need to figure out how can we collect data that actually can be used throughout the information flow I've just shown. And by that, I mean, we probably design alternative construction schedules and actually develop the safest version of those that then finally gets implemented. Once that is being implemented, we actually are able, and you can see hopefully the cursor here, we can collect raw data and measure its performance and link that to the digital twin for construction safety. I make it brief because I will show some examples. There is the digital twin platform that consists of 3 to 4 components. I think 2 of them actually can be combined. So let me talk about maybe them individually. One is very important, following the prevention through design and planning principle, which designs out hazards that we know of that usually would exist in the field. And I will focus here on fault protection when I go into the examples. And that could be almost seen as virtual reality, applying virtual reality, but not quite. But again, we design out hazards before they appear in the workplace. That is proactive in the design and the planning phase of our project. When we then go into the construction operations phase, like we face the reality, we of course update our models that have been designed safely, but yet may, due to the complexity in the dynamics of a construction site, may change very quickly. And then we have to have technology in place that actually warns us. So let's say the teleoperated autonomous reloader actually drives, and maybe we don't know it exactly the pathway. Then we have to warn workers when they get too close to it, and so they don't get hit. So here we have a right time analysis and mitigation tool that applies. And last but not least, while we still do conformance checking of other physical environments that we have in the place, we also need to perform some learning from it, right? Because any of these data that we have from the planning phase, as well as all the way down to the real-time monitoring and instant feedback we share with the workers, we actually also have to use that in learning environments. And here, this virtual reality safety learning comes into place. So there's very typically very complex detailed processes to follow. Actually, here we sit down with companies to evaluate their existing strategies and processes, and we find out what is it actually that we want to design out in terms of hazards, and how do we alert the workers, and how can we give them feedback that is valuable. So typically this relates to a very detailed process analysis. Likewise, we have done in BEEYONDERS with some of the participating partners in building and road construction, and I go into the first phase. So typically that's what you see wherever I travel around the world. I take photos of construction sites. That one I took in New Zealand. People have, of course, a risk assessment and perform that just before they execute work. And here you can see they actually write down what the hazards are and how to mitigate them. And yet they use a physical board on the job site that is posted on the fence so everybody can see it, even visitors like me on a job site. Okay. Again, there's an expert in place that does it. Typically, that person has a lot of knowledge versus the workers once in a while get training. And again, that's already a bottleneck. We should provide them probably with more training and feedback than just once. So here we have it. Here we have a construction project. We have several stakeholders involved, in this case, the workers and the safety manager, and they have domain knowledge, in particular this person here, and they need to apply rules and regulations. We can analyze them and yet put that into the digital representation of the job site. And the term building information modeling came up already. I mean it, and it's very early when we talk about BIM and safety. Actually, there's not that much in safety in BIM that I wish there would be. But typically, if you follow this process here, we could create a digital representation of the work site before we start working. Let me give you an example. Here we have the typical regulations on fault protection. There is code that we can code it according to the regulation. For example, for a hole that is bigger than 5 centimeters, or for a leading edge on a work phase, where you can drop almost 2 meters or 2 meters or more, you should install fault protection, a cover, a guardrail, or whatever. And it looks like that. It depends on which country you are. In the EU regulation, it would like that, but in the US, it would look slightly differently. Again, this may relate to international projects. Some of you have it, maybe some of you don't, but it may also add to confusion to the workforce that is traveling throughout the world. Let's say in Europe, we currently built the Fehmarnbelt tunnel link between Germany and Denmark, and the workforce is 80% from Eastern Europe, most of them actually from Poland. And I believe they have very strong safety regulations, but when they come to Denmark, they may not know those in detail, even though both are in the European Union. Okay, so here updates would be useful. Now let me show you what BIM and safety means in the prevention through design and planning phase. On the left, you see a BIM without safety. On the right, you see it. We simply run our code checker, our safety rule checker on the BIM model, and it creates the guardrails. That's it. And you can import that into the schedule. And actually, it provides a lot of value already about where and how to protect leading edges in this particular case. Once you tie that to the construction schedule, you see a bunch of things going up. This is actually the 7-story building going upwards. But at the same time, we can tell you in what part of the schedule, the construction schedule, the guardrail needs to be implemented. They're saying red needs protection. And likewise, we can measure a KPI on the total length of guardrail. Likewise, we can create alternative schedules, like a baseline plan using one crew. It would look like that, very uniform. If you would add multiple crews to speed up your production, you actually would get such a schedule, and even that one could be optimized. So we have tools in place and created that can create not only a safe construction plan using BIM, but also a safe schedule. Okay, so these are two important ingredients because we use them later on in our virtual reality-based training. Okay, I continue. The SafeCon AI, I mean, we could call it AI, this very famous term, artificial intelligence. But here we have a tool that allows you to actually draw the information from the digital twin platform and figure out, okay, has it been actually installed like as planned? And you can see it here. We left it actually quite usable for humans. Somebody draws by hand in this variable device. There should be something. I'm missing something. So I've identified and located that position. And actually, once you hit submit, it will find that safety element that is there. So even though this is augmented reality in this particular case, it also relates to this, extended reality concept, where you try to give people in the field feedback as they requested. So this is drawing information from the digital twin platform, indicating that here is a guardrail element missing. And by the way, all of these experiments were done under supervision, so none of the students that actually developed the technology gets harmed. You can see that here there was a scaffold just below, just in case somebody would get close, that would be a protection for them. Okay, good. So this is really good stuff. If you think going away, flying with drones, everybody likes that. I hope people don't do bad things with drones. But we can actually record information, and this is done with our partner in the BEEYONDERS project from Finland, Fira. And you can see here we fly with drones. We create point cloud, and these point clouds get analyzed by computational algorithms. We have created a DTU to figure out, are these elements in place or not? And yes, we can do it. For example, here on the left, we can see there's a guardrail element missing, there's the toe board missing, and there's the top board missing. And that was implemented with live tests on a job site, again, safely conducted. But when you fly with a drone, I make it very brief. You can create point clouds from stitching all the photos or videos that you collect, and analyzing these point clouds and linking them to your safe designed BIM model allows you to figure out where modifications occurred or that don't align with your model. So really cool stuff. I think that's right for a startup company that does that professionally. We would be happy to participate or share and collaborate with you. Showing you a little bit what we do currently on our campus, similar to what we are doing in BEEYONDERS. We actually fly with drones. These are so-called Hoffman blocks in Denmark, where we separate walkways from machines. Again, aligned with the BEEYONDERS project, our goal was to figure out, are these Hoffman blocks all in place where they should be? So we have a safe BIM layout. That's the plan view of it. You see here the container or the offices, temporary offices on site. There's a walkway, and all where you see these dashed lines everywhere here should be Hoffman blocks. Again, this is drawn based on a BIM model, so don't think that this is just a made-up figure. Actually, this is the plan view of a BIM model, the site layout plan. Then we fly basically every week, at least once. And it's surprisingly, well, everybody loves to look at these images because they're so detailed, and yet nobody has the time to actually figure out, okay, how many Hoffman blocks, protective guardrails are in place to separate pedestrian walk patterns, walkways, from vehicles. And here we apply our algorithm using labeling. I mean, standard techniques. It's not really that difficult. And I highlight here a bit more where we see these Hoffman blocks automatically detected. And as the excavation progresses, actually we see that they add step by step more or modify them. This is existing technology. At least our algorithms. Again, it could be moved to the next level. Really nice application that safety professionals in the field want, and the reason is that they actually want to go know just before they go in a safety meeting what has changed on the job site. They don't have the time to look at everything, but if drones and AI applied to the photos or to the orthomosaic images actually can give them some information, like processing data and getting relevant information out. I think that's one good thing for them to improve their decision making. Okay, you all are aware of AI and have seen many applications. I must admit, some of the stuff I show here is 15 years old. I mean, at least in this slide, where others are still are so fascinated about AI, but it has been around for a long, long time, where we have written papers on using vision detecting walkers below crane loads, or actually using wireless technology to track walkers in the field. Yes, there's a whole bunch to respect in terms of GDPR and privacy rights and all of these things, completely understood. And yet we in research at universities, we like to explore the boundaries and let others then add their comments on what is doable and feasible. But we can really nicely see that the crane load is swinging over walkers where it should not. Actually, we can log these events. You can't record the faces of the walkers here anyway, but even here you can record the trajectories of walkers and actually linking it to the visibility of a crane operator, tower crane operator. In this particular situation, the walkers actually went through blind spaces that the operator could not see. So a very interesting concept. At some point, you will see such technologies appear on job sites where they do real-time monitoring. There's no doubt about it that it has to happen just to protect the workforce. I took this video just to introduce you to the next topic where we go into right time alerting and monitoring. This is a video I took. I was on the phone. Sorry for this shaking because I had to tell the guy, please stop talking. I need to take this video. But this is what happens on typically job sites. There's a formwork element spinning due to high wind loads in the field, and luckily nothing happened, that this thing dropped. But a very dangerous situation. So that triggered the moment in the BEEYONDERS project for me to investigate this a bit more. And luckily, we had our partner from Finland on board, and we investigated here what are dangerous situations where crane loads could be below walkers. And again, it relates all to building information modeling, because BIM models have these 3D object representations in place. We know when and how they get built. We also know eventually by the room element about where active work will happen. And then we can measure, okay, do we have crane swings over those active workspaces or not? And if they do, well, we want to prevent it first of all. But if we do, are only those people in the place that are allowed to be there? And if not, can we actually detect and monitor it? That's what we have been doing. Sorry, it sounds a bit complicated, but we have followed two approaches. One is vision-based cameras, similar to what you have seen before, like using labeling and detection and tracking. The other part focused on RTK GNSS, very good for outdoor environments, especially horizontal projects. Horizontal projects meaning that I'm talking about infrastructure projects, but here we applied RTK GNSS, which is nothing else than high precision GPS in the field of building construction. So in the BEEYONDERS project, we looked at the building construction case, and we actually investigated whether we can track prefabricated building elements, because they are very dominant in the Nordics, in the Nordic countries. You can see it here, the crane is swinging, and actually we have a cylinder, a virtual cylinder around the crane load, and we see right away that there is two walkers below. Actually, only one of them should be there, I must admit, because he's the rigger. He puts the element into place. The other one, I must admit, could have been there, could have left the area a bit earlier, putting the grouting down for the prefabricated element. Yeah, and so a lot can be seen by visualizing data. Again, some people may refer that to virtual reality, and in fact, it is not. This is just superimposed data from the field, from the IoT, from the sensors, on top of a building information model. You see here the building information model that is enriched with this information. It tracks and documents behavioral and we can conduct a behavioral analysis of when these things occur. Typically, of course, when lifts are being delivered to the site. So really interesting that we can collect information from the field very precisely down to the centimeter level and actually keep it for visualization. I will relate to this incident later again when we go into virtual reality. Sorry for having such a big review ahead of time, because you need to see the complexity of our virtual reality environment. Like here's another result. You see here such an element being lifted. We can identify on the job where these load swings over workers happen. And again, an image like that, yeah, some people refer to not real anymore, but it's definitely a sort of extended reality. Actually, you can localize that and actually think about how can I make my crane swings safer with all of this information. The blue lines here are the crane swings. And when they go over walkers, then we create here a circle. You see a lot of stuff happening here, even though the job site didn't look that busy. This is just qualitative analysis, by the way. There's very little quantitative data that I show you, but I want to show you that this is also possible in horizontal cases. I must admit this was a different project, but very much relates to the road construction use case in BEEYONDERS. We can collect so much data about being 1 meter distance to the machine and following blind space diagrams. There's a whole another presentation I need to give. But yeah, all of these trajectories can be linked to the trajectories of the vehicles. And we can actually figure out in this plan view of this job site here, again, you can see here the green are the walkable areas that are supposed the workers to take, but yet you see they're deviating from it. And likewise do also the machines deviate and they go into areas where they shouldn't go in. And then we can actually start predicting in which areas of the job site do we have very close interactions and is something going on. And you can see this here. This is this spot here. The walkway that is designated for the workers is not wide enough. So our recommendation to the people in the field was just make it wider, add another 2 meters. It wouldn't limit your productivity, but actually you can start preventing all of these close interactions between the walking pedestrian workforce and the equipment that is traversing on this job site. You can imagine this machine was going back and forth a bunch of times to load rail cars for a subway rehabilitation project. And here we can predict actually as part of a digital twin, we should not just shadow data, we should actually predict locations and get rid of them, prevent future incidents that are likely to happen. I hope this is not too fast because I have to move quickly now to virtual reality. And what you can see here is the learning triangle, learning pyramid. Of course, we want to go into gamification because it's much more fun to actively play instead of listening to a lecture like I give here or read text. And the question is, where are you, right? Are you doing toolbox meetings? Yes, you probably do. I have attended many of them actually conducted. Or do you have on-site training like this great contract I had in place where you have to tie off? So really nice. And yet I think there's more we can do at much less investment. I never talk about cost in safety. I talk about investment in safety. And virtual training is actually a good thing. How does virtual learning, the virtual learning concept work? Well, we have a virtual environment, we have maybe the gaming principle, and we have a hazard library. And all of them get bundled. I'm not going into the technical details here to a construction safety game where predominantly the trainee interacts with. And that's what we often see, right? People have a virtual learning environment for safety induction, and they have to pass certain events, and then they get certified, and then they're allowed to go to the job site, or they have to recognize hazards. But that's relatively straightforward, and many of these things exist. What's more interesting is actually that the trainee gets individual and instant feedback, like a summary about the performance. And most virtual reality safety training is for visualization purpose only, where they replay videos or anything of that, but very few actually give detailed objective feedback to the trainees. I know this is a bit short, but likewise does the instructor need to get this feedback, and not for the individual trainee, but for everybody in the group, right? Because often it's multiple trades that work on a job site and not only a single person. And that feedback can be shared. Likewise, can the trainee provide self-reflective evaluation to the instructor, which overall makes the creation of a virtual reality game very interesting. So we have to create it, which relates to a lot of technical issues. And I'll go into that in brief in a second. And then we use the game, and also there's this third component about sharing feedback. Now here you see a game. It's kind of a it was created within a few months actually, because we had a very skilled person, Mario Wolf, who assisted me on this. Here is a very nice little game that gives you hazard awareness, and yet it's just there to let you figure out, are there hazards in a place or not. Okay, and you see here the scoring principle. It's actually based on reward. The higher you score, the better you perform. Eventually you can compete with others, and so on, right? And so on. I may move this here a bit quicker just to show you. There's a lot of things that you typically see or may at some point in your life encounter on a job site, like a fire and so on. Or in the next situation, things laying around, but other things that are safe. But here is somebody cutting, not using the PPE, and you can recognize the hazard and actually provide it to the worker. Please don't take it for granted that everything that is implemented here is 100% correct. It depends highly on what virtual reality libraries are available, because we are not having the time and resources to actually do a lot of 3D modeling, like you see here, the helmet and so on. We use existing assets that we need to build the scene. If I jump here, I may jump now a little bit, because it's actually very complex to go from a single virtual learning environment to a multi-person environment, and we are creating this right now. That's Killian's work. That is not just involving multiple people, like the rigger or a crane operator and a signaler. Currently, we are working on more than 10 people environment that all work simultaneously in the same scene, performing their tasks. And even though we are not completely finished yet, it's very promising to get the data and the results from it. And to make it even more interesting, you see here the complexity in setting up the technology. They actually also have augmented virtuality, where we create the haptic feedback for the people. So they should use in a multiplayer, multimodal virtuality environment also the tools that they would use in reality. And here we work with machine tool manufacturers. Basically on our effort, you can see here somebody's cutting a pipe and the disc starts spinning. Smoke is being generated when you trigger the button on the machine, and actually then the same behavior appears in virtual reality. I had to show this here on the screen because that's actually what the person there using the head-mounted display sees. And again, we wrote a really, really nice journal article about this hazard training. And you can see here, somebody should have shut off the valve before and released the fluid because it created an explosion. Coming back to this example with our project partner from Finland, again, we had the data from the field and we knew that signaling crane load swings is important. All of those can be also considered in a virtual learning environment. I jump here a bit quicker because you will get the slides and the recording later. Here you can see we are in this environment. There's a crane operator actually working with the rigger, and we use this smart glove. Again, there are startup companies that work with us on developing this and integrating that into virtuality. Actually, when the rigger uses the smart glove indicating lowering the load, then the crane operator actually lowers the boom and grabs the load. And likewise, the load is being lifted if the signal here says hoist the load. I hope you have followed this. I know it's all fast. If not, contact me later. I share more detail. You can see this here too. Here the load is being lowered. The load is being lifted and being put in place. This is the third-person view, probably the trainee would take. The trainer would take just to document what has been going on the job site. Now, when we play with this, this is serious playing, right? I mean, often people criticize me when I say playing because they think it's just fun. No, serious gameplay means that there's a serious purpose behind it. We can actually detect and track in that safe virtual learning environment whether workers are exposed to crane loads or not. And yet no harm is happening to them, but we can show them like this. Killian, I think, has done a phenomenal job and keeping the feedback simple as possible, saying, okay, here the rigger is being exposed to the crane load. Maybe that person is stepping to a safe waiting area before the load is lifted. And up here, when the load is being placed, of course, the workers here should stay outside. Okay, just to give you brief feedback, data can be recorded, analyzed. We know by the second what happened and how. Here, actually, Killen came up with, okay, well, if communication could improve using this hand glove, the smart glove from the rigger, signaling maybe in blind lifts in particular, we could reduce the lift time by about 6%. And if you think about that, crane lifts are among the most significant and important tasks in a job that limit your productivity, then you can value this 6% increase a lot. I must admit, this is an academic measurement, and you may criticize academics that we are often very theoretical, but again, nothing hurts us from implementing that in real world and validating it. So let's do it, right? Here's my proposal to you. Coming to Beyonders, to the teleoperated reloader, I think there's different webinars on this. I'm not going into depth, except that this machine and the sensors that are built onto it collect a lot of information. Some of that I've shown you already, but there's even more. All what we are interested in the virtual reality serious gaming environment is to create very realistic virtual learning environments. And you can see this here. On the left, you see the job site. On the right, you see virtual reality. So there is a high likelihood, and we show it here, we prove it, to create very realistic learning environments. Yeah, and sometimes I must give feedback or share the result with you. People appreciate it if it's not as realistic, if it almost has like the character of a comic. You all are probably familiar with cartoons and comics. Keeping it simplistic, not overwhelming them with what they see, and keeping it different from reality to make sure that they understand that reality is serious, even more serious than virtual reality. Okay, here again, Killen has done a phenomenal job on a project related to a light rail project. Again, he has several participants playing, and I'm not repeating what I've said earlier, that we can show these locations and the times when these incidents occurred in virtual reality, where the worker stepped too close to the equipment. What I want to rather focus on is feedback does not necessarily be always negative or criticizing. No, there can be encouraging feedback, and virtual reality allows you to do that. In reality, on a real job site, it's very hard to monitor everybody because everybody's busy, especially safety inspectors that hardly have time or hardly are called to visit and inspect a job site. Like in virtual reality, you can encourage people, focus on this a bit more, focus on this a little bit less. And maybe we can even figure out what are the predominant hazards that people should focus on. I can tell you maybe a couple of quantitative results that I don't have in my slides. It takes about 2.5 to 3 seconds to recognize a hazard. And we have done the tests in comparing reality versus virtual reality. It still is 2.5 to 3 seconds to recognize a hazard. In virtual reality, even the best performer recognizes only 2/3 of the hazards. So there's a long way for those who are performing extremely poor in a virtual learning environment to recognize above 30% of the hazards. Yeah, even the best performed and recognized only 2/3. So even for the best performer, they have to improve tremendously to recognize all kinds of hazards: falls, struck by, caught in between electrocutions, etc. Right? There's a really nice paper I can share with you if you want to contact me that goes into much more of these quantitative assessments about why virtual reality learning has a big advantage. I go into something completely different. You may wonder, why is there such a poor safety behavior on construction sites? Well, actually, we train our kids the wrong way from the get-go. This is from a bookstore in Germany. In German, there's one publisher in particular who came up with this Wimmel books. These are hidden object books, and several of those relate to construction. I must admit, I probably have the largest library from all publishers around the world on this topic, construction. I have hundreds of these books, hundreds. And I thought, and I looked at them and I thought, what's going on? Are we why is construction so unsafe? And yet, in these books, if you look into them, they have a lot of embedded hazards, and that's for me a starting point. Well, kids may not use virtual reality. Actually, adults have also this issue with virtual reality sickness. Actually, that's why we go into a multimodal environment where some of them actually sit in front of a screen and participate in such a serious game. But going back to the kids, we train them the wrong way. We give them impressions about what construction sites look like, and they learn it the wrong way. So we have created actually a board game based on virtual reality. It's being released later this year. And Beyonders, I've played with partners in the Beyonders project. They loved it, and they were adults, right? This board game is super fantastic, based on virtual reality, so we can take virtual reality back to conventional learning methods, like you can see it here. That's just part of the game. It's really like almost a professional game you could commercialize. But again, we're academics, and so we want to improve the society or the industry. But we've played in a lot of countries. These are just two examples where I was at conferences, and thanks to Beyonders, this was possible. Finalizing thoughts, very quick. Human factors and work environment matters a lot. Virtual reality has to include most of it. I don't have the time to explain this. I'm running out of time. But there's a long way still to go to create really good training environments. Yes, we can create the impact even with virtual reality. Here's just some examples. One predominant was once we got on the cover page of New York Times. Sorry, not the first cover page, the cover page on the business section. And that tells us there is business to make in this. Even though we may want to focus first on increasing the safety and health of the workers. I always say we have a three-step approach to transform the industry from linear and experience and reactive towards circular. Circular, I mean the information. We need to go from experience to evidence. We have a shrinking workforce. Virtual reality can help us create objective feedback and thus evidence of what are the behavioral changes that are needed. We need to go from reactive to proactive. There's no question about it. We can't let workers into an unsafe work environment. That's why virtual learning and IoT and sensing can create such feedback. While there's a lot of other stuff, I think this is the Bradley curve. It basically tells you what you need to do to go from an idea all the way down to saying we go from technology and standard implementations to behavioral change. So it's a long road of journey. We typically say 15 to 20 years it takes to implement a technology. So what you see coming out of Beyonders probably will be in the field in about a decade or a bit more. Unfortunately, I've started with this 20 years ago, and yet I don't see some of my applications being commercialized or embedded, which makes me wonder a little bit. But hey, a lot of people will focus on this topic. That's why you're here today too. So I'm not giving up. But what's important is technology accurate? Like even virtual reality, is it reliable and is it helpful? I think these are the components I can relate to. Last but not least, we all know these movies. I just highlight two of them. They can be really interesting, but on the other side, we have 1984. So we need to keep that enclosed as well. Because there's nothing to say then, people need to use it in the end. Otherwise, why do we develop it? We know this one. You've seen it many times. I don't think that artificial intelligence will replace humans unless we automate the entire process, and then humans are not needed anymore, and we do something different. Yeah, fine. But yes, we as humans are really, really skilled, and long way. That's why always economists value human capital above anything else. Neither machines, processes, methods. Human capital is the number one decision criteria in many of our businesses. The reason why we have so many incidents, it's because of human issues or human-related issues. Key takeaways, a lot of stuff to do. When you get the slides, you can read through that. Again, I see technology as an enabler, not as a replacement, and yet a long way to go that requires academic and industry collaborations. Thank you. This is my contact information. Feel free to reach out. I'm still very excited about this topic. Thank you.
Thank you, Professor Teiser, for your presentation and the insightful content that you shared. Thank you also for sharing the contact at the end. I hope you don't mind also if I share the email contact on the group chat, so that also people maybe in the meantime can also copy paste it directly
Sure.
from there. And I now open also the possibility for people to write any question in the chat. You might also be able to request your microphone to be open in case you want to directly speak with the professor. I will be glad to do so for you. So I will just wait a couple of seconds and see if someone have anything to ask.
I think if you allow all of them to speak, it's fine. If they want, it's the fastest.
Absolutely, yes. If the only fact is that I can allow them one by one. So
Okay.
I don't want also everybody to be obliged to
Maybe
take the
nobody
word.
has questions. That's another opportunity. Fact.
That's
Overwhelmed.
possibly the case, but again, since the professor kindly shared his contact with all of you, again, feel free really to reach out to him or to the project, as you will also find the info@beyonders.eu email in the group chat. So feel free to contact any of us. The only thing that in the moment in which I do not see any questions still coming, maybe I have one question for the professor as a potential key takeaway for people at home, in the sense that you quite interestingly mentioned the development of a board game, which sounds like something very interesting also for the people attending the meeting today. Should they, would like to take part in this initiative, will the board game will actually available somewhere in the DTU website? Is this something that is going to be actually made available for the public, or is more like an internal scientific experiment, socially speaking, obviously?
Yeah, once done, we have to think about what's the proper outlet. I think one part is the haptic feedback, like playing with cards and the board game and the figures and everything. I think even though we could think about an opportunity to release a virtual reality version, the first stage would be the game, and then yeah. But we'll think about it. What's the best way to release it? And as you know, even if you have to pay €10 or $10 or whatever to get a physical copy, I think you will enjoy it. These board games are very inexpensive for what you actually get. I must admit, yeah, people don't make much profit of that. But I think in this case that we have it right now, the physical board game makes a lot of sense, even though a virtual reality component could be developed easily.
That sounds amazing. So thank you also for sharing it. And I hope that all of us might be involved in having the chance to play with it. So still, if there are no questions from the public, and I still do not see questions coming on hands raised, then I take the chance to thank Professor Jochen Theiser for your time and sharing all those information. And thank you to people participating today. And I hope we will have the chance to speak of those topics soon via email or with another meeting. So thank you very much.
Thank you.